So the fifth topic is Gauss law of electrostatics. So let's revise that quickly. Gauss law of electrostatics. So if you had a plus here and if you had a minus here, the electric field lines flow like this. So the arrows are coming out like this. Okay. If I take a closed Gaussian surface, so let's assume something like a sphere around here. So that's my closed Gaussian surface. So everywhere in this Gaussian surface, the electric field lines are, is it coming in or coming out? It's actually coming out of the surface, right? So all the lines are coming outward. So that means I will say phi E is equal to Q enclosed divided by epsilon naught. So I told you, the book doesn't say enclosed, but it's better to write it like this because it's whatever is inside the surface. So outward flowing electric flux is there. So net electric flux phi E is there. So there is some value for phi E. On this side, I will say inside this Gaussian surface, do you have any charge or not? You have some charge, which is this one, right? So that means there is some enclosed charge. Charge is enclosed inside the surface or Gaussian surface. Okay, so this is one case. So let's assume, take the same thing, minus here, going like this, going like this. So all the arrows are coming out again. But suppose, let's assume that the lines are like this. Let's assume that I take a Gaussian surface at this point. Okay. Everyone following this? I'm just saying that the charge is there, which means Q enclosed is not zero. There is some charge. And similarly, there is some electric flux which is coming out, which means it's not zero. It is there. When I say it is there, means I mean there is some value. Okay. So now look at this. If I take a Gaussian surface like this, again it's a closed surface like a sphere. So what can you say about this point here? The arrows are coming in or out? It's actually coming in. What can you say about this place? It's actually coming out. Okay. So the electric flux will be calculated from coming in minus going out. Okay. So the net electric flux in this closed surface flux lines in is equal to flux lines out. So I'm going to say, so the net flux is equal to 0. Because whatever is coming in is going to go out. Also notice Q enclosed is equal to, what is Q enclosed here? Is there any charge here? Is there any charge? No, that means Q enclosed is 0. So if you apply the Gauss law, you will see that this is 0, this is also 0. So this is case 2. Any doubts here? So in that case, you have a non-zero electric flux and non-zero Q enclosed, whereas in this case, both are 0. So that is for Gaussian law for electrostatics. Now we need to talk about, so the fifth topic again, that is just a repeat of what we already know. So the Gauss's law of magnetism. So in this case, anybody remember what is the main difference between the electric field lines and magnetic field lines? Static. Positive to negative, okay. North to south, it's correct. So this is north, this is south. So it goes like this. But does it stop here? What does it do? It goes inside here. So that means it is continuous. Okay. Here it is not continuous. Okay. So so take it down. Electric field lines are not continuous. Okay. It goes from plus to minus and stops. Whereas magnetic field lines, they don't stop at south. Yeah, but then it just stops there. There is no inside flow. Okay. Is there any charge, this thing line from minus to plus? Whereas here, it's not like that. Okay, it's already time, so let me quickly finish this off. Okay, so I'm going to say, maybe I'll talk about this in the next class. So suppose if I take a field here, Gaussian surface, just like what I took in the case 1, right? So whatever is at this point, the lines are coming out or going in? It's coming out, right? At this point, it's going in. So whatever is coming out has to go in here. Do you agree? That means flux in is equal to flux out, which means the total flux will be 0, right? And in this Gaussian surface, what is the magnetic pole? Just like the charge here, you have only north, right? So the south is not there, right? Is that correct? But probably you are not remembering. I am sure you have done this kind of experiments in your childhood days. If you take a magnet and if you break it here, what do you think will happen? This will become south and this will become north. Which means even though I see only north here, there is actually a south here. If I break this, there is a south here. If I had one plus and 1 minus, what is the Q enclosed? 0. Plus 1 and minus 1. So similarly, north and south means it will be 0. So I am going to say flux in is equal to flux out. So net flux is equal to 0. Qm enclosed. So Qm stands for magnetic charge. Okay, so that is electric charge. Here we call it as magnetic charge or the pole strength Qm. So Q enclosed is also 0 because so Gaussian law of magnetism says that net magnetic flux through any closed surface. So net magnetic flux through any closed surface is 0. That's all. So if they ask you what is Gaussian law of magnetism, this is what you have to explain. This is a statement: net magnetic flux through any closed surface is 0. Okay. If you want, you can write one more step here. So QM enclosed. Okay, let's not confuse you.